Alright, we're gonna look at this kind of Olympic math level geometric problem. Alright, so I have this triangle ABC here. Now I have an internal point P and I draw a parallel line, a three parallel line to the three bases here. Right, this notice here, this TS, right, will be parallel to AB. Right, that will be parallel here. And the other one is similar, so everything is parallel. Alright, so let's undo that. We're given the tiny triangle here. This triangle is T1 here. The area is 4. The other one is, this one is 9. This one is 49. Okay, we know the areas. Alright, so let's clear that. So one thing we know, because they're parallel, so we know that there are a lot of similar triangles, right? So we're going to first review the properties of similar triangles, all right? So here we're going to review the properties of similar triangles. So if two triangles are similar, then we have the following three properties here, right? So the first one is that corresponding angles are equal to each other, all right? And the other one is that corresponding sides are proportional. And the other one is about the area. It's that the area of the two similar triangles, the ratio of that triangle equal to square of the ratio of the sides, corresponding sides. So the key word here is a corresponding. All right, so we need to find out which one is corresponding. So let's say ABC, right? In this case, ABC is similar to DEF, and usually we write corresponding angles in the same order here. So which means in this case, A would be corresponding to D, B would corresponding to E, and C was corresponding to F. In other words, A, right, would correspond to D. This angle would equal to each other, okay? And F would correspond to C, and E would correspond to B. So we have three angles equal to each other here. This is the first property. The second property is that the sides are proportional. So in other words, this is a right. Now the second property will tell us that AB corresponding side is going to be DE. The ratio of that would equal to AC with DF, and also equal to BC over EF. So this is the second property here. Now the third property is saying that because the ratios are equal to each other, and the area, right, of ABC area, the ratio of the area of DEF would equal to the square of the ratio of the sides. So the ratio side would be here, right? So we square it. So in other words, would be equal to AB, the length of AB, over length of DE, and then we're going to square it. Alright, so that's a key. For example, if this is 3, if this is 5, we will know that the area would be 3 over 5 square would equal to 9 over 25. Alright, so now let's go back to our original problem, right? So we were given that in this case T1 equal 4, T2 equal 9, T3 equal 49. And we know that there are a lot of similar triangles. Triangle number T1 is similar to number T2, similar number T3, and a similar triangle of ABC. So we need to find the area of ABC, but we're given the area of T1 equal to 4, this equal to 9, this equal to 49. So we just need to find out the ratio, right? So we need to find the ratio of what? Of the size, right? So let's pick some sides here. So we need to find out the ABC, which is the side here, right? And we need to find another, let's say pick anyone, right? Let's say pick this tiny T1 here. The side, the corresponding side would be this one, right? So I need to find this short side and over this longer side. So in other words, we need to find what is the ratio of FM over AB. So if we know that, right? So if this is known, then we know that the ratio of T1 over the area, that is, we need to find, right, ABC would equal the whole thing square, right? Alright, so how do we find that? Alright, so we're given T3 and T2. It's very important to realize that we have a few parallel lines here. So this, let me use a different color here. Let's look at this, right? So because this line TS parallel to AB and MM parallel to PC. So what we get is that the PS must equal to MB. Alright. Now similarly, when we look at the other small area here, this is parallel, right? So from here we know that TP would equal to AF. Alright. Now from the property of similar triangles, we know that the area of T1 over T2, T3, and this equals, we know that this is, we're given this is 4 over 49, right? So we look at this triangle here, over this triangle T3 here, and the corresponding side would be, MF over PS square, right? This is a property of similar triangles. Now, however, what is PS here? So notice that PS equal to MB, right? So PS equal to MB here, right? So, alright, so we can change this to MF over MB square, right? So, since this is 4 over 49, so from here we know that MF over MB must be 2 over 7, alright? So if this is 2, here, this would be 7, alright? Okay, so let's assume this is 2x, then this would be 7x, alright? The whole thing, this, in other words, if MF equal 2x, then MB must equal 7x, right? Because the ratio is 2 to 7, right? So you may ask, what is x? It doesn't really matter, x is some number, right? So now similarly, what is the area of T2 over T3? Right, so we're gonna T2 over T3, we're given that the ratio would be equal, because T2 equal 9, That's over 49, right? So T2, the corresponding side square, right? This is property of the similar triangles. Now we are given that this T2 is similar to this T3 here, right? So the corresponding size would be this one, which is TP over PS, right? So it's TP over PS. Now, however, earlier we know that TP equal AF. So this one, TP here, is equal to AF. So I rewrite this as AF over PS squared. So in other words, this one equal to this, right? Equal AS, right? So we're gonna say, because this is equal to 9 over 49, right? Which is, 9, which is the 3 square over 7 square, right? So we're given that AF over PS would equal to 3 over 7, right? So where the AF, now here we know that PS is equal to MB. In other words, PS here equal MB, right? So these two equal each other. Now earlier we know that MB equal to 7x. So here this equal 7x, right? So in other words, equal to AF over PS is 7x. So because the ratio of this, equals 3 over 7. So if PS equals 7x, the AF must equal to 3x. So AF equal 3x. Now notice that we try to find the area of this, right? We know T1, and we know we need to find out this ratio here, right? So do we know the ratio? So let's find out what is the ratio of FM over AB, right? So FM, we know that is equal to 2x here. What is AB? AB here is the full length here, the full length AB is equal to the summation of the, AF plus FM plus MB, right? Now MB equals 7x, right? The MB equals 7x, FM equal 2x, and AF equal 3x. Okay, so that equal to 2x over 3 to 7, that would be 12x. So equal 1 over 6. So the ratio is 1 over 6. We plug in here the 1 over 6 squared. That would equal to 36, right? So what is the area of ABC? T1 times 36. So the area of ABC equal T1, the area of this tiny triangle. This is a T1 here, T1 times 36. T1, as we know, it is 4. 4 times 36. This equals 144. So the final answer to the original problem is that this is equal 144, right? So because the ratio here is, this is 2 over, this is 7, and this is going to be 3. So the whole thing is 12, right? The whole length is 12. This whole length is 12, right? And this tiny one is 2, right? So let me review that, which is T1 over the area of ABC equal the square of the size ratio, which is 2 over 12, which is equal 1 over 36, right? This is 1/6 square. All right. So the final answer is 144.